Hello, students. The fundamental theorem of linear maps has a lot of consequences right off the bat. For example, if T is in the set of linear maps from V to W, and the dimension of W is less than the dimension of V, then T is not injective. Okay, so how can we show this? Well, what do we know? We know that the dimension of V is equal to the dimension of the null space of T plus the dimension of the range of T. Right? So the dimension of the range, well, the range sits inside W, so it has to be less than the dimension of W. So this is less than or equal to the dimension of W. So I could write this. But now I know that the dimension of W is strictly less than V. So this is less than the dimension of the null space of T plus the dimension of V. And keep in mind what I have on the left. I have the dimension of V on the left in all of these. So what could I do? Well, obviously subtract the dimension of V from both sides. And what do I have? I have that the dimension of the null space is bigger than 0. So that means that there is some non-zero element that gets sent to 0. So two things, 0 already gets sent to 0, and pick something in that null space, that also gets sent to 0. I have two different things that get sent to the same element. So if you pick a V not equal to 0, so V is in the null space, which we can do because the dimension of the null space is not 0. And then notice T of 0 equals 0, which is equal to T of V. And that shows that T is not injective. Okay, well, we can do the same thing. What happens if I flip this? Or something similar. Not the same, but something similar. So if T is a linear map from V to W, what happens if the dimension of W is bigger than the dimension of V? What happens then? Well, or I should say, otherwise I'm not really doing a proof, right? I'm doing an investigation. Then T is not surjective. It means we don't hit all of W. It means that there's some element of W that's not in the range. So let's try to figure this out. Once again, we'll start off by just writing down the fundamental theorem of linear maps. Okay, so what do I know now? Well, a little bit trickier. What we have to do here is, hey, the dimension of null space, whatever this is, it's 0 or more. So what I could say is that the dimension of V is equal to this plus this, which happens to be greater than or equal to the dimension of the range of T. So I have the dimension of the range of T, which happens to be less than or equal to the dimension of V, which happens to be strictly less than the dimension of W. So the dimension of the range here is not all of W. So that means that there's some vector that doesn't get hit, and thus T is not surjective. The range isn't everything. Some elements do not get hit. So those are the first two immediate consequences of this theorem, but there are more in the next video.